Coakee William Wildcat is the founder of Mother Tree Food Forest. He's on the board of directors of the EcoRestoration Alliance, and he's the director of the School of Constructive Arts. He integrates Western science with modern and ancestral agroecology and land management traditions. Trained in the Miyawaki Method with a forest, he weaves together a long list of approaches, including syntropic agroforestry, agroecology, Elaine Ingham's soil science, landscape water retention, mycology, ecology, botany, and indigenous agroforestry and ecology land management systems, all into a single school of thought. Please welcome Coakee as our next and last speaker of the day.
And thank you, Louise. I have had some tech issues today. I wonder if you all are hearing me right now.
We are. We hear you well.
Okay, wonderful. Yeah, my name's Coakee William Wildcat. I'm from the Oklahoma Seminole Nation, Cougar Clan, Thomas Palmer Band, and I've been doing biodiverse polyculture organic gardening for decades and food forestry for 15 years and studying soil microbiology for 20 something. To ecological restoration work and really focus on right now, I'm focusing on advancing agroecology and ecological restoration in arid climates, especially in hot, arid desert climates. Centered in the U.S. Southwest, working in the U.S. Southwest and Northwest Mexico. And I really appreciate the opportunity to speak on this, and I'm honored to share the screen with so many brilliant people. I've really appreciated everything people have contributed today. And some people have already illuminated some of what I want to talk about, which helps me a little bit to just sort of move through and get to the heart of what I want to discuss. I guess to mention some of the projects I'm working on right now, I'm on the Texas-Chihuahua border, that's the United States-Mexico border, doing a watershed and ecosystem restoration assessment project. It's including Miyawaki-style PNVs for some different ecozones to create a toolkit for this part of the world. And what I think is a pretty progressive way for the United States right now to do eco-restoration in coherent ways, whole watershed restoration, ecosystem restoration within that watershed in some very coherent ways, including planting ecosystems with the urban greening money that's coming in here instead of putting trees on life support. I think all the presenters today understand what I'm talking about, and I bet a lot of the people in the audience do too.
Coakee, can I interrupt you for just a second? Some people are having trouble hearing you. I don't know if you can speak up or hold your mic. Yes, thank you so much.
Sure. Yes, absolutely. I'll do
Yes, that
both.
is better.
Okay. So, yeah, working on a Miyawaki-style PNV as a part of a watershed and ecosystem restoration project here on the Texas-Chihuahua border, which is pretty exciting, working with a forest on this project. In southwest New Mexico, we're doing a project where we're planting 3 Miyawaki forests and 3 food forests adjacent to each other, 1 reference each, and then 2 experimental plots each. And one of the things we're experimenting on we're looking at with the 2 food forest test plots, one of them we're planting with, Miyawaki biodiversity and density, and all the other pieces of Miyawaki reforestation, except that these are non-native, but still climate adapted food species. And we're looking, and with the Miyawaki test plots, we're testing to see how indigenous agroforestry wisdom can empower Miyawaki reforestation to accelerate the rate of growth of that forest and some other variables. And so, and then I also include Miyawaki reforestation in some of the tree and shrub aspects of successional agroforestry. So I want to define some things. Agroecology is working with ecosystems to get our food and materials in our agricultural system. So really studying ecosystems, studying ecological succession, especially so that we understand how to work with ecosystems to get our food and materials in ways that are mutually beneficial to all of life, to all the beings and the ecosystems that we are a part of, which is really in our best interest. Successional agroforestry is a subcategory of agroecology that really studies and understands ecological succession to empower that agroforestry, which often mixes annual crops with trees and shrubs with woody perennials. Syntropic agroforestry is a subset of successional agroforestry, which is this beautiful marriage of indigenous agroforestry from northern Brazil, which is very advanced, with a little bit of Western science that was packaged in a way that looks like industrial agriculture, so that it's understandable to the techno-industrial mind, to the mind of basically the predominant culture in the world now, so that we can interface with this very developed system more easily. Why successional agroforestry? I think that agroecology, Miyawaki reforestation and agroecology are both types of ecosystem restoration. And I think that agroecology is the most important type of ecological restoration for us to engage in, because it's the most widespread, most direct to our personal experience and everything. If we're doing, ecosystem restoration work, but we're getting our food from supermarkets, so we're voting with our dollar to support industrial, even if it's industrial organic, we're still voting with our dollar for ecological catastrophe. And so if we can all focus on and not give up until we have figured out ways to supply each of our communities through local agroecology, then that is the largest scale ecosystem restoration that we as a species can do. So I think this is where we should focus and begin. And I think that Miyawaki reforestation is this beautiful system, this very complex, developed, elegant system that has come through Western science, with some indigenous roots in Japan and Germany, from what I understand, that can really empower us doing that. But I think that we should be focusing on agroecology if we are concerned about the climate and ecology crises on this planet. And so that's why I'm speaking to this today. Food forestry is a type of agroecology, agroforestry that really helps us get our needs met in ways that are natural to us. We're a foraging species, so food forestry is very, very important. So that's a form of agroforestry, which is agroecology as well. The elements of Miyawaki, what makes Miyawaki so powerful? Well, I mean, we basically all know we're putting a sufficient amount of organic matter into the soil. We're putting sufficient populations of biota and fungi into the soil food web. We're putting in a sufficient minimum biodiversity with a minimum density, three-dimensional density, not just two-dimensional spatial, area-wise, but the full canopy stratification, which comes from biodiversity. But then also we're studying canopy structure, the geometry of the canopy in analog sites that we go to study in person when we put together the potential natural vegetation P&D surveys as a preparation to this. And so we get that three-dimensionally dense system, which creates a strong small water cycle. Because we're planting everybody very close together, we've put the fungi food in the soil. We're putting in the ligneous species, the trees and shrubs, which feed ectomycorrhizal fungi and create lignin, which feeds the saprophytic fungi at the surface. We've put in all this fungi food and all these fungi partners, created an environment where fungi can live and thrive, and planted everybody very close together. So very quickly, every individual organism, every individual tree and shrub organism in that system connects into this mycorrhizal network, which connects in with itself. And within a very short amount of time, every individual sapling has connected into what is now becoming a metaorganism, a single organism with many cells in the body. And we know now that every tree and every fungi organism in the forest is connected, sharing resource and exchanging information and strategies about the environment. And so very much like the cells in our body, exchanging resource, exchanging information. So when we say metaorganism, we say that the forest is a single organism. This is an understanding. That word was translated from a Brazilian indigenous language into Portuguese, into Spanish, and now into English. We don't really have this aspect of that metaphor in the English-speaking world yet, but it's arriving now, and it's a very important idea that I'll talk about for a moment. Because it matters, because very shortly, because you put everybody in so closely together, different categories of plants feed different categories of fungi. So different plant species feed different fungi species. So because we have a minimum biodiversity of plants, we have a minimum, therefore, biodiversity of fungi who will find their way there and establish, and eventually everybody connects in. So we have biocomplexity, and very quickly after beginning a Miyawaki forest, every individual sapling has connected into what has now become a single biocomplex metaorganism. So that whole fungal and microbial network in that whole area has now become the collective root system of every single tree. Every single plant, tree and shrub in that system now has this huge, very biocomplex root system, essentially. And so now it's very, very hard for that organism to fail. And that's one of the reasons Miyawaki reforestation is so powerful. So metaorganism, yeah, metaorganism also organizes, like you have climate data in a plant, like in the seed of an acclimatized, say, apricot that you have grown 3 generations where you live, you have climate data in that seed. A metaorganism collects, it organizes, connects all of the information, all of the strategies that every organism in that meta-organism contains individually, and organizes it into biocomplexity and into what Anastasia Markaryeva said is much bigger than what we think of as intelligence. A lot more information processing, a lot more complex strategies, and real-time control system manipulation, like something bigger than what we think of as intelligence. Meta-organism is a very important concept that gives us agency in agriculture and ecological restoration, and really gives us agency in the climate and ecology crisis on this planet. And so it's a very important concept that's still missing from our culture, and that's why I speak on that. A small water cycle is another important concept that I don't think most of us understand the entirety of. When you have a 3-dimensionally dense forest, you have a physical system where a water molecule that comes in is forced to cycle more times soil, plant, air, and then condense in that humid air in the morning and be absorbed back in, be eaten by small microbes, roll down the plant, or drip from the leaf back into the soil. So it might go soil, plant, air more times before it's physically able to leave that system. So water efficiency, small water cycle. Also, you're creating soil which holds that water, keeps it from falling through into the mineral area and dropping down to the aquifer. You have a floating aquifer underneath a forest that is the soil and the soil food web, which holds that water there. So water efficiency, so it can be used again. So it's not dropping below that system. It's not escaping the air. There are a lot of ways that this is true. And I want to get to some more important parts, but I could speak on that for a long time. So density creates a strong small water cycle, 3-dimensional density, full canopy stratification, plants very close together. We're mass producing organic matter. We're accelerating the rate of accumulation of soil, which is increasing the floating aquifer that we have. We're physically preventing water from escaping into the atmosphere. When the wind blows 20 miles an hour over the top, it's blowing 1 or 2 miles an hour inside of. This is the exact opposite of competition, the competition scarcity lens that we sort of have to extrude our worldview through here in the techno-industrial world. And Miyawaki and Elaine Ingham and Lynn Margulis and all of Suzanne Samard, all these people are helping us get out of the competition scarcity lens and remember that we have concerts and concerts and concerts of mutualisms. And that's what's really going on here. It's not as simple as just cooperation, like holding hands, spoon feeding each other. It's not simple, it's complex, a whole lot of gray area, but it's definitely not survival of the fittest. Competition model. Small water cycle means local water economy. The more dense, the more developed, the further we go in ecological succession from desert to grassland to forest to mature forest, the more efficient that organism becomes with the water that comes into it. Ecological succession is very important to understand. Desert turns itself to grassland, turns itself to forest, turns itself to mature climax forest. There are ways to make that pause at, say, grassland, for instance, but it's usually human beings who are doing that. All over Turtle Island, North America, they were human beings who used fire and different other management strategies to maintain pockets of grassland. You know, the way the grasslands were maintained in the Great Plains, the way they were created and maintained is still remembered by a lot of indigenous peoples over this continent. It's important to understand ecological. We don't talk about ecological succession in this culture. We don't understand it. We need to, for our agricultural systems, to have more agency with our agricultural systems. We really need to understand ecological succession to have agency in the climate ecology crises. It's wonderful that Miyawaki has figured out this amazing trick to skip all the stages of ecological succession and go straight to climax forest. It's amazing and really powerful and wonderful, and it's a natural thing to marry with these very developed indigenous sciences that still exist in Mesoamerica, Northern South America, and probably other places in the world I've not studied outside of the Western Hemisphere. We're talking about critical thresholds a whole lot, which is very important. We're creating we're trying to pass critical thresholds. We deforest 50% of the world, and we cross these critical thresholds going the wrong direction, and now the planet is desertifying. Miyawaki is an example of how we can cross critical thresholds going the other way, and we can pull back at it after 3 years, no more supplemental irrigation, nothing, and we've triggered a forest event. So we've crossed critical thresholds the other way. And everything we're looking at, like in biotic pump, we cross critical thresholds to where now this forest can irrigate itself by manipulating global climate. It can control the large water cycle. It can control global hydrologic cycles and irrigate itself if we can empower this forest, if we can cross these critical thresholds. So, you know, we deforest the Mediterranean part of Europe, and now that part of the world can no longer irrigate itself. We think that there's, you know, critical thresholds that we can reforest enough that it can start irrigating itself again. That's what they're working towards with the Green Belt movement in Africa. And so that idea comes up a whole lot and is really important. I just wanted to mention metaorganism, small water cycle means local water economy, ecological succession. We really do need to study that honestly and learn a whole lot more about that. And, you know, we as a civilization and culture and anybody interested in ecological restoration or agroecology, we should really be studying ecological succession. And then critical thresholds, just paying attention to what they are, and more experimentation as we get more money to do more research in all the different aspects of ecological restoration and agroecology and everything. Miyawaki, understanding and identifying these critical thresholds, which aspects of this algorithm apply everywhere, what should be adapted to unique locations, what trends hold true across all climates, bioregions, ecozones, etc. So some myths that Miyawaki reforestation sort of disproves include that, you know, the competition, scarcity mythology, like I already spoke to, just layers and layers of concerts of mutualisms and symbioses is what's happening here. None of us can get all of our needs met unless there are hundreds of thousands of species all dogging to get their needs met. We have this mythology that the amount of water in an ecosystem predetermines a finite amount of biomass potential, and it does not. We see that through regenerative grazing. We see it through the Miyawaki method. We see it through all these other examples of how, you know, same ecosystem, we change the animal behavior, and suddenly there's just orders of magnitude more biomass. The amount of water falling in a system maybe defines like a window of the amount of biomass possible, but it does not predetermine the amount of biomass possible. The behavior of the animals in that system and which plant species are present in that system together determine where we are in that window. That's very important. The ecological effects of animal behavior are extremely important in all of this and just completely misunderstood, not thought about to the extent that we need to. So that's another area that we really need to bring our attention as people interested in climate and ecology action. And then also, yeah, the concept of individuals, that, you know, that tree is its own organism and it's dogging for its needs and it's survival of the fittest, competition, scarcity. Miyawaki method disproves that. Metaorganism, just complex mutualism is what's actually going on here. It's a cell within the organism. The cells in your body are not competing with each other, right? They're not individuals competing in a cold, hard world. We're working together for the health of the whole organism. That's what's happening in a forest. That's what's happening in a successional agroforestry or any agroecology system. So some examples of the way Miyawaki reforestation or the Miyawaki method empowers agroforestry. One is it allows us to do real successional agroforestry, real syntropic agroforestry. When you hear people talking about how they're doing syntropic agroforestry in, around the world. It comes from Brazil, and there are people doing it on every continent now. You hear a lot, we had to adapt it to the system, and then you see people not actually following the procedure. The algorithm, the methodology to syntropic agroforestry includes basically the whole Miyawaki method. Planting density, minimum biodiversity, minimum density, full canopy stratification, all of these things. And people, because we have this competition scarcity lens still affecting our worldview, our ecological worldview, interfering with our ability to understand what's actually happening, we're reducing density, reducing biodiversity, and just sort of like kind of pretty close to monocrop. Maybe we're growing 3 tree species and not allowing the biodiversity that we need, the density that we need, any of it. And so we're not getting the nutrient densities that we could be getting. We're not getting the water efficiency that we could be getting. We're not getting the resilience of that farm that we could be getting, because we're afraid, because we're acting out of fear, because we're not really acknowledging what we learn, what Miyawaki proves and disproves. So if we trust what we learn from the Miyawaki method, then we can trust what Ernst Gotsch and the indigenous people from Northern and South America have taught us about how ecosystems work and how agroecosystems work and can work. So we can really do real successional agroforestry and real syntropic agroforestry if we really honor what we learned from the Miyawaki method. Another way that it relates directly to the agroecology that we're trying to do here is in regenerative grazing. In Mexico and on other continents, people are already planting little pockets, inoculation pockets of forest in their regenerative grazing ecosystems. And that allows so much more resilience, so much more biodiversity, so much more biocomplexity. Biocomplexity is what allows resilience, by organizing all of this information and all these strategies and everything to create a coherent, intelligent system that has agency and is adaptable. So we create so much more habitat for more species when we put little forest, just inoculation points in our regenerative grazing system. Doing Miyawaki style food forestry, trusting what we know from Miyawaki reforestation to plant with high density, full canopy stratification, climate adapted, but non-native food species, food forestry, trying to make food for ourselves very close to home to satisfy our own food needs, for food security, for economic security, for cultural preservation, for self-determination of every community. This is very important. We can plant Miyawaki style, minimum biodiversity, minimum density, 3-dimensionally, and then we can have more water efficiency from that system so that we have more, just a higher calorie production per unit water going in. So for every unit water going in, we have more food coming out if we can trust what we learned from the Miyawaki method. And remember, there are successful Miyawaki forests in deserts in Iran and India, and hopefully soon, I'll help that be so in Southwest New Mexico and Southwest Texas. We're working on that right now. And so, but it's been, proven that that these forests are more water efficient. It's been shown. And I'm working on that. We're doing an experimental one in New Mexico right now, a Miyawaki style food forest that hopefully we'll get great results from that. And we need to have more of those in more climates, ecozones, bioregions, et cetera. Please help with that. And then Miyawaki rows in syntropic agroforestry, we can just do native species rows as the tree and shrub rows in syntropic agroforestry. So we're growing our annual crops in rows with trees and shrubs, annual crops, trees and shrubs in rows. And so those tree and shrub rows, you can do every other native species forest and every other food. You can mix in food species with those native species. There's different strategies. The thing about syntropic agroforestry as opposed to regular organic agriculture is that when a syntropic agroforest garden goes fallow, what you have is a highly productive food forest. That really means something. When a regular organic farm goes fallow, it turns back into desert fairly quickly. And so desert or highly productive food forest, big difference there. We see from the not perfect P&Vs that are done, and we see from syntropic agroforestry that those guilds that mix non-native and native species together, that those guilds that mix species from different stages of ecological succession together, they can still function as resilient metaorganisms. We see that everywhere. You don't have to have the PNV perfect. And in fact, in North America, where we don't really have climax forests, it's very hard to do that, to make a good PNV anyway. Nobody's making great PNVs in North America. We're getting different plants of different stages of ecological succession, different plants that didn't really go in that ecozone together, that weren't really real guilds to begin with. We're getting them together and they're working. In syntropic agroforestry, we're mixing native and non-native species together and they're working, they're establishing functional resilient metaorganisms that when you stop irrigating, they stay alive. They keep doing their thing. It's a forest.
Coakee,
Yes.
you won't believe that the time has passed already.
Oh, okay. You know what? I do believe that. And I've said so much of what I wanted to say. Thank you for your patience and generosity with time.
But if you could wrap up what you were just saying, we would really appreciate that. That is another obviously deep dive of information. And we'll start to take questions after that.
Yeah, thank you so much for the opportunity and for this forum. I really love sharing this. I think that this is all very important for every reason. Like I said, yeah, I think that, I've spoken to how Miyawaki advances agroecology, and it's also true that agroecology advances Miyawaki. Miyawaki was from Western science, so it doesn't have all of the wisdom that the indigenous sciences that are thousands of years older than Western science have. And so it's, some decades old, and there's room for modernization and updating it with everything we know collectively as a species now. And I'd be happy to speak to that at some other time, and I'm ready for questions.
Wonderful. Yes, I think we could host a whole nother summit just with you talking, Coakee. Everything you're sharing is so rich and so meaningful, really, really incredible. Thank you so much for sharing a small portion of your wisdom. So I'm going to thank you so much for people who put questions in the chat. If you have any other questions, please put them in the chat, and we'll try to pull out the ones that are the most relevant to what he's just been saying. So I'm going to start off the first question with asking you, how can we learn to listen to the forest as a living, breathing community rather than just a collection of species? And what practices and perspectives help us tune into the wisdom that's carried by all the beings that make up the forest?
Yeah, thank you for that question. And what a joy that Hartman opened this, and that we get to close with a question like this, or at least near the end. Yeah, how do we listen, and what practices? How do we learn to listen, and what practices? For me, it begins very simple. It's just making time. How do I learn to listen? Like studying what is listening, making a study out of deep listening, spending time with big trees, big rocks, spending time with water, learning to respect these beings as spiritually conscious beings like myself. Quieting my mind, quieting the language center in my mind when I'm spending time with these beings, coming to respect and honor them, asking to know them and to be known, spending time with my mind quiet so that there's nothing interfering when they want to share with me. This is my practice. These are pieces of my practice. For me, I think for a lot of us, a lot of the natural medicines, there are so many ways that we are nature. We are nature. We are not separate. We are a part of the forest. We are a part of the ecosystem. Wherever we are a part of that ecosystem. And there's so many forms of communication. Western science is just discovering them left and right. We just discovered that plants communicate with each other via infrared. We know about so many hormones and pheromones, and every being has the same endocrine hormones that you and I have. Every being, bacteria, fungi, plants, we're co-regulating our own endocrine systems with all the beings out there. One of the systems of communication are the psychedelic plant and fungi medicines. They're invaluable in reconnecting lines of communication and opening up lines of communication. They're invaluable in healing trauma, which helps us clear out the interference that helps us, and obviously there are a lot of choice points along the way. It's not the medicine itself, it's how we use it, it's how we choose to use it. So having real reverence for these sacred medicines and using them specifically for the purpose of healing ourselves and coming into healthier relationships with myself, with each other, with all the beings that I'm in society with, and the ecosystem that I'm a part of. That's, I think, a very big important way. And then, like plant dietas, like when we stop eating other foods and stop communicating, we go out into nature, we spend, a few days in nature, and I'm just eating the leaves of one plant for a few days and smelling them and touching them, spending time with that plant, asking for communication with that plant, asking to receive wisdom from that plant. The plant dietas, people do this in a lot of the world. It's not so common here in North America, but it's really making a strong comeback quickly because it's such an effective way to open up lines of communication in the ecosystem we're part of.
Wow, Coakee. I mean, definitely got me moved to tears. I have a question from Rob Christopher, who's an urban forester. And he worries that the trees that he's planting in the tree wells, like in sidewalks or like little orphans, and he's wondering how they can thrive if they can't tap into the mycorrhizal fungal network.
Yeah, in situations like that, I think about earlier succession. The earlier successional species are designed to work with less partners, with fewer partners. And so there are tree species that will germinate in dead dirt, baking in sun, and they can establish, where I live, juniper, pinon, creosote. There's, many examples. And so that's what I think in those situations, you just want to plant trees that have evolved to live without a lot of partners, and then you're just putting shrubs in underneath. Make sure they have some teammates, The more partners you put in with them, so you plant some trees with some shrubs with a bunch of forbs together, and then the more teammates, the more biodiversity, the more biocomplexity you establish, the further in ecological succession you can pick trees from. And then different plant species have different windows of where in ecological succession they can thrive. Some have these huge windows like juniper. Some have very small windows. So, just understanding ecological succession again, so that we can understand how any particular plant species interfaces within ecological succession.
Okay, great. Thank you so much. So another question from Nicholas Garon is there a critical threshold for the size of a Miyawaki forest? And, maybe in both directions, is there such a thing as too small a microforest or too large? And do benefits multiply at large scales? He really wants to know more about those details.
The quickest, most honest answer to any ecology or biology question is always the same. It's like, I don't know. It depends. Let's do the experiments and find out. I think in a question like this, what climate we're in, it plays a huge part in what is that minimum critical threshold of area. I think it's a wonderful question that should be explored where you are. I think that's going to vary probably in a harsh, hot desert, high elevation, harsh, hot desert, low elevation, or in, wet climate versus dry climate. I know that there are places where a 6-foot diameter Miyawaki forest has established and thrived. I imagine those are wet places. I don't know if that could happen in the desert, but it's an important question. I'm going to go out on a limb with, again, we've not done that research to answer the opposite question, how large is too large? I'm going to go out on a limb and say not too large. We're in no danger of reforesting the entire planet yet. Let's do that and then see what problems come from that.
I love that. I love that recommendation. Thank you, Coakee. Well, we just have a couple of minutes left, so I'm going to end with this question. You've talked a lot about PNV. If you could define that, just take a minute to define that. The question is, when engaging in potential natural vegetation or PNV research, how do we move beyond creating a species list toward forming a real relationship with the land and its communities?
Thank you. Yeah, for that question. I love that question as well. I want to make sure that I remember to say thank you to Biodiversity for a Livable Climate. I love what you all are doing and the fact that you've identified that life regulates global climate. That's invaluable, and the role of biodiversity, that we need biodiversity for the biocomplexity that can make coherent, resilient systems that have agency to irrigate themselves, to survive different climate extremes because of the information that they're coordinating as a metaorganism. I love the vision of Biodiversity for a Livable Climate and all of this wonderful work that you all are doing, that you're all hosting this, the beautiful people in your organization. I have so much love and appreciation for the work you're doing. Thank you so much. So going beyond P&V, that we're not just putting together a list of plant species, but we're connecting with those ecosystems that we're studying, that we are really conjuring up from history and from analog sites a story that is no longer being told, that none of us remember in an area, you know, and what was the role of real relationship in that process versus just like looking things up online. You know, we have to remember this is the most this culture is the most separated from its food that any culture has ever been in Earth's history. And therefore, this is the most ecologically illiterate culture that's ever existed in Earth's history. So when you're looking things up online, I mean, you know, I mean, I don't think this is hyperbole. I think that universities, that Western academia, I just call it industrial academia, is designed to maintain markets for products and services that we need to not exist. Not only do we not need them, but we need them to not exist. And so people are receiving indoctrination. There are people coming out of universities with ecology degrees, conservation biology, agronomy degrees that don't understand ecological succession, don't understand soil science, don't understand ecology, climate physics. I mean, not at all, zero. And so when we're looking up anything online, please understand that the ecology wisdom held in the Miyawaki tradition is beyond anything in the predominant culture, even out of universities in this country. I don't think that's hyperbole. I honestly don't. So we have to go out into nature to do PNVs if we want to do a reasonably coherent job. And again, this is an aim, and this is an asymptotical aim, you know, because there are not analog sites. You know, those forests were destroyed, biodiversity was lost. Succession, ecological succession, it takes hundreds or thousands of years for a climax forest, because what is a climax forest, you know? Is it the species that are left, you know? And so, you know, this is an asymptotical aim. We're just trying to do the best we can do, and the best we can do is great. We're doing a wonderful job. Everybody's doing a wonderful job. I'm really hearing Casey Lee. What a beautiful being. I really appreciate everything so many people have contributed today, especially including Casey Lee. Say, like, we don't shame people, like we're trying to heal together. We don't open with shame, we don't middle with shame, we don't close with shame, we keep the shame out of it. So I'm really going to spend a lot of time, I'm just recommitting myself to the study of how to remove that component. So I heard that in my language just now. I want to acknowledge that I'm aware and thinking and making a study of that. Thank you, Casey Lee.
I love
We're
that.
doing it. The best we can do is the best we can do, but we have to be out in nature. We have to be in ecosystems, and it's through, you know, a lot of time going back to the same sites, really establishing relationship and looking more closely to where we're seeing more and more and more of the interactions of the relationships there, because we're trying to mimic those guilds, those structures, those everything when we're putting our PNVs together. And it's through developing relationship. Yeah, I mean, I could speak longer, but I imagine we're short on time.
Yeah, that was brilliant to end it that way. Thank you so much. I think that gives us good direction on where we all need to go next, is just all these suggestions and encouragement you have on spending time quietly in nature. Well, Coakee, it was just incredible for you to wrap up our summit today. Really brought a lot of richness. I want to thank you so much.
Thank you. Really appreciate the opportunity. And yeah, I love you all. Thank you.